What we have here is a closed loop speed simulator with a speed control here driving an all-electric actuator. The speed control is getting its speed signal from a magnetic pickup. Controller here is driving a DC motor, so as the speed control requires more fuel, it's going to send a DC voltage, higher DC voltage to drive it faster. As it needs less fuel, it's going to give it less DC voltage and it's going to slow it down. So we have a complete closed loop system here running speed control. What we have here is a magnetic pickup looking at a 60-tooth gear. The amplitude out of the magnetic pickup is dependent upon how fast the gear is spinning and also how close it is to the gear itself. So we'll look at the amplitude here a little bit later. As each tooth goes by and it counts each tooth, we're going to get an AC sine wave, and we'll see that on the oscilloscope a little bit later. We have a potentiometer being driven by the actuator, so as we increase fuel here, it gives it the potentiometer more voltage to drive the DC motor. That's going to increase or decrease speed on the motor. This is the electric power governor. It actually controls the speed, sending its output to the actuator. The inputs to the EPG are 24 volt power, output to the actuator, input from the magnetic speed control. We have 3 potentiometers on top here to control the PID and adjust the PID parameters to the controller. What we're seeing here is each magnetic pickup tooth as it passes by. Now, as I said before, the mag pickup amplitude is dependent upon the distance between the mag pickup and the gear. As I back the mag pickup out, you'll see the amplitude decrease. As I increase, it gets bigger and bigger. As I adjust the time rate on the oscilloscope, you'll see that we have some amplitude modulation in here. That's caused by the run out in the gear. As I put some load onto the gear, you'll see the actuator call for more fuel. So just putting a little pressure on there causes the actuator to go to more fuel, and you'll see the PID action bringing the control back into rated speed.